So I just want to start off by saying I have a little bit of a cold, so I might cough. So sorry, Julio, if I cough. I'll try to cough away from the computer. Okay, number 1 wants us to describe the transformation of f of x cubed represented by g of x cubed equals, or g of x equals the quantity x minus 8 cubed plus 3. So remember, numbers on the inside, shift left and right. This is going to go right 8. And the number outside is up and down, and it's the same as the sign. So it goes up 3. If I didn't know this, I could graph it on my calculator. I go to y equals. Sorry. So I type in x cubed. And then for my second one, I do x minus 8 cubed. And I go graph the 2. If you're using the school computers, the first one would have been blue. Of the computer's calculators. The second one would have, I didn't get that right. I forgot my plus 3. Okay. Anyways, school calculators, that would have been blue, and this one would have been red. Okay, so I just want to sketch my graph. So this one is f of x, and then the second one that graphed was g of x. So the little turning point, I want to make sure I move over 8, up 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, I want to do the same thing on number 2. This time it's got a plus 4 and a minus 9. So this is going to shift 4 to the left. And the 9 goes down. I can graph this on my calculator. So only the second one will change. So g of x f of x stays where it is. And then g of x, sorry, I kind of want this all to be on the screen. G of x moves to the right, sorry. I move to the left 4 and then down 9. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then I curve up, and then I curve down. G of x. Okay. Number 3 wants me to factor this completely because it is 2 terms. I know I'm going to use one of my 3 formulas up top. Difference of squares has an exponent of 2 with a minus in between. Sum of cubes is exponents of 3 with a plus in between. And difference of cubes is exponent of 3 with a minus in between. Okay. So this one wants me to factor completely. The x has an exponent of 3, so I want to find the cube root of 64. I'm going to rewrite this. If I don't know how to find the cube root of 64 on the calculator, I want to go to math. And then if I look at choice 4, that'll give me the cube root. I type in 64, and it tells me it's 4. So I want to rewrite it as x cubed plus 4 cubed. X cubed is going to, or just x, is going to be my a value, and 4 is going to be my b value. So I am plugging in, they have a plus in the middle, I am plugging into the sum of cubes formula. So when it says a plus b, it's just going to be x plus 4. I write them without their exponents. Then I have a squared, so that's just x squared, minus a times b, so minus x times 4, plus b squared, so 4 squared. Then all I want to do from here is I just want to rewrite this. So in my first set of parentheses, I have x plus 4. In the second set, I have x squared, that doesn't change. Negative x times 4 is negative 4x. 4 squared is 16. Okay, and that's my answer. I'm going to do the same thing on number 4. This one has a plus, so I'm going to use the sum of cubes because the exponent on the x is a cube. Then I want to find the cube root of 8. I know this one is 2. I could check on the calculator if I didn't. X is my A, 2 is my B. I'm plugging into the same formula as above, so it's going to be x plus 2 times x squared. Then it's A times B, so that's x times 2, and then plus b squared, which was 2. Okay. Then I want to simplify this, so I have x plus 2, that doesn't change. Then I have x squared minus 2x plus 4. Okay, number 5 is going to be a difference of cubes. So this is similar, except I have the minus in between. So which formula I want to use is the difference of cubes. Okay. So I want to find the cube root of 343. So remember, I go to math, choice 4, 343, which is 7. So I have x cubed minus 7 cubed. Then I want to rewrite this. I'm going to have x minus 7 in my first set. Then the formula goes a squared, so just x squared, plus, this is always opposite the sign right there. Okay? So plus a times b, so x times 7, plus 7 squared. Then I want to simplify. So I'm going to have x minus 7 times x squared plus 7x plus 49. And that's my answer. Okay. Number 6 works the same way. So I have x cubed. Cube root of 1,000 is 10. Minus 10 cubed. So I plug this in the formula. I'm going to have x minus 10. Notice, if this has a minus, this will also have a minus. These two pieces always have the same sign. And it's going to be x squared plus x times 10 plus 10 squared. Then I want to simplify. So I'm going to have x minus 10 times x squared plus 10x plus 100. Number 7, this has 4 terms, so I want to factor by grouping. And I should say up here, I use the formulas on the front when there's only 2 terms. Okay. So, factoring by grouping means I break it into 2 pieces. So this first group gets broken up and the second group gets broken up. Then I focus on what each set of the numbers have in common. So I'm looking for what 3x cubed and 2x squared have in common. Both of these cannot be divided by the same number besides 1. But they both have x terms. So what I'm going to do is I'm going to take out the lowest exponent, which here is 2. So I'm going to take out x squared from both of them. So I write what I've taken out on the outside. And what I get left over is what goes on the inside. So I have 3x cubed divided by x squared. It's going to turn into 3x. 2x squared divided by x squared. This cancels out and leaves me with just 2. I'll do the same thing over here. So I'm looking for what divides negative 12 and negative 8. They're both negative, so I'm going to want to make the number I divide out a negative. 12 and 8 can also both be divided by 4. So I'm going to divide out a negative 4. That gets written outside. Then negative 12 divided by negative 4 gets me positive 3x. Negative 8 divided by negative 4 gives me positive 2. Notice, because these are the same thing, 3x plus 2, I can rewrite it so that the outside pieces get combined together. So I'm going to have x squared minus 4. That's combining the outside pieces together. And then I just write the duplicated piece. I only write it once. Then if I look at this, so the kind of trick I use for deciding if I can factor more is I look at my exponents. So I'm going to ignore the first piece right now. If I look at this term, my exponent is 1. I definitely cannot make that any smaller. However, this one has an x squared, so I want to see if it's a difference of squares, which means does it have a minus in the middle? It does. So I want to factor this more. This one is going to use the formula on the front, the difference of squares, because it's a perfect square minus another perfect square. So I'm going to have a plus the first term and a minus the second term. So that gets me the square root of 4 is 2. So I have x plus 2, and then x minus 2. And then this piece didn't change, so I just write it again. Okay. Number 8 is the same thing. So I want to split it up into two groups of 2. I have this group and this group. And looking at my first group, they're both even and divisible by 2. They also have exponents, x with the exponent of 2 that can come out. So I'm going to take out 2x squared. 2x cubed divided by 2x squared is the 2's cancel out. And then I subtract my exponents on the x's. So 3 minus 2 is just 1. 4 divided by 2 is 2. And then my x squareds cancel out. Over here, I have negative 32 and negative 64. Both of those can be divided by negative 32. So I write negative 32 in between. Negative 32x divided by negative 32 is x. Negative 64 divided by negative 32 is positive 2. Then I rewrite these pieces together. I have 2x squared minus 32. And then the x plus 2 gets written at the end. Notice on this one, they're not perfect squares, but they are both even. I can pull out a 2 out front. So 2x squared divided by 2 is 2. 32 divided by 2 is 16. Okay. Now it is a perfect square, so the square root of 16 is 4. 2 stays where it is. Then I have x plus 4 for my first set. X minus 4. That's taking care of this first one and splitting it up. And then the last one, x plus 2, just goes at the end. Okay. Number 9 wants me to find the quotient of the expression. I can do this by long division or synthetic division. When I was looking at your responses to the survey I gave you guys, I noticed a lot of you said that you didn't understand how to do long division, but none of the test questions asked you specifically to pick long division. You can pick synthetic division. I am going to pick synthetic division. You don't have to know long division. So to do synthetic, I write the L looking thing. Then I want to write my coefficients of the top piece. So I have 1, 5. Notice there's no x term. So I want to use 0 as a placeholder. So it's going to go 1, 5, and then 0, negative 5. Okay? For the number that I'm dividing by, I want to change the sign and write outside. Okay? So instead of being a positive 3, it's going to be a negative 3. Then what I do is my first number always goes down. So I'm going to have just a 1. To get this number, I take the outside number and the bottom number and I multiply. So negative 3 times 1 is negative 3. I always multiply these two numbers. I never multiply this number and that number. That's not something I want to do. I noticed that mistake a lot on the quiz. So then, I always add down. So 5 minus 3 is 2. Let me make sure that was in there. Okay. Then I have 2 times negative 3, gives me negative 6. 0 minus 6 is negative 6. Negative 3 times negative 6 is positive 18. Negative 5 minus, or plus 18 is positive 13. So then what I want to do is I want to put back in my x's, but I start one exponent lower. So originally it started with a cubed, so when I plug back in, I'm going to start with a squared. So I have x squared, because the 1 doesn't need to be written out front. Then I have plus 2x minus 6, because I don't write an x after the next one. And then the extra number, this gets turned into a remainder. So I have plus 13, and it always goes over what I was dividing by. So over x plus 3. So same thing on number 10. I am going to start by writing my numbers on top. I have 1, negative 4. I again have no x term. So I have 0 and 3. And then I want to write opposite this sign. So opposite of negative 2 is positive 2. I bring down the 1. 2 times 1 is 2. Negative 4 plus 2 is negative 2. Negative 2 times 2 is negative 4. 0 minus 4 is negative 4. 2 times negative 4 is negative 8. 3 minus 8 is negative 5. Then I plug back in my x's, so I have x squared minus 2x minus 4, and then the 5 turns into a remainder, so I have minus 5 over x minus 2. Okay. So number 11 is giving me this graph, and it wants me to find and label the relative maximum and the relative minimum, and then say where the function is increasing and decreasing. So, the first thing it's asking for is the relative maximum. Remember, this is the high point, and then relative minimum is low point. So I'm looking for the highest point on the graph that is a mountain. I don't care that it goes on forever. I care that it turns into a mountain. So this coordinate point, if I look, this graph did not print out well. 1, 2. So my x value is 2. And my y value is 1, 2, 3, 4. So my relative maximum is the coordinate point 2, 4. My relative minimum is the point -2, 1, 2, 3, 4, -4. So that's the lowest value. Where my function is increasing. So this is where I have a positive slope. So right here is a positive slope. I have a positive slope, and I also only look at x values. Okay. So I have a positive slope between the x value of -2 and the x value of 2. So I have, this is interval notation. So I write it in between -2 and +2. Then it wants to know where the function is decreasing, so where I have a negative slope. That's here and here. So this is left of -2. Over here, this is right of +2. Why did I not write the -2? So, remember, the way I write left in math is -infinity, and I said to -2. And then that takes care of this first one. Then on the second one, I have 2, and the way I write right in math is positive infinity. So this is saying from the left side all the way up to -2, it's got a negative slope, and from x value of 2 to all the way to the right forever, it's going to have a negative slope. Okay. This one is going to work the same. So I want to figure out my relative maximum, the high point. On this graph, it's on the other side. It's 1, 2, so -2. 1, 2, 3, 4, +4. So over here, it's going 1, 2, and 1, 2, 3, 4, down 4. Okay, so where the function is increasing, where it has a positive slope. It has a positive slope right here, so that's the left of -2. Remember, I write left with -infinity, and -2 gets written with -2. On the right side, it's also increasing, so this is right of 2. So that's going to be 2. You always write the smaller number first, to infinity. Because remember, infinity means right. Okay, then I want to give where the function is decreasing. So with a negative slope, it's in between -2 and 2. So I just write my x values. Okay. This one wants me to say if the function is odd, even, or neither. So what I do for this is, if it's odd, if I plug in -x and it's odd, I get out everything changes signs. If it's even, nothing changes signs. And if it's odd, I already said odd. If it's neither, some change signs. Okay. So I'm going to plug in -x. So if I have f of -x, then I'm going to plug in -x, and I have squared minus 1. So -x squared, any negative number squared, turns positive. So I have x squared minus 1. This is exactly the same. So exactly the same is even. Okay. This one I'm going to plug in -x. So any number to an even power stays positive. So this is going to turn into x to the 6. Over here, I'm going to still write my negative in the middle. A negative number to an odd power turns negative. Let me make that. Okay. This one, because I pulled the negative out front, because before the negative was just with the x, now the negative is out in front of the x, it's going to change and make it go to x to the 6 plus x cubed. This stayed the same sign, but the x cubed didn't, so this one is neither. Okay. On C, I'm going to do the same thing. I have f of negative x equals negative x to the 5th times negative 2 times negative x cubed. Because these are both odd, they're both going to go outside. So I have negative x to the 5th times negative 2 times negative x cubed. This one I'm going to multiply together. So I get negative x to the 5th plus 2x cubed. Originally I had a positive, now I have a negative. I originally had a negative and now it's positive, so this one is odd. I'm going to do the same thing with number 14. I am going to plug in a negative x, so I have f of negative x equals negative x to the 6th power minus negative x to the 4th power plus negative x to the 3rd power. So this is an even exponent, so it turns positive. This one is an even exponent, so the x stays positive, but the negative out front from right here stays. And then this one is an odd exponent, so it turns negative. So if I compare, stayed the same, changed, so this one is neither. Okay. C, I'm going to plug in negative x. Okay. This one is a negative exponent, so it's going to come out negative. And then the x stays negative. I'm just going to change my sign right now. So over here I have positive 3 times negative x, so it turns into a negative 3x cubed plus x. So these are opposite, opposite. So this one is, when the sign changes, it's odd. Okay, then for f, I'm going to plug in negative again. Okay, it's got an even exponent, so it stays positive. This one, the negative in between stays. And then it's got an even exponent, so it stays positive. This one matches up completely, so this one is even. Okay. Number 15 wants me to prove that this works when I plug in the given values. So I'm plugging in 4 for x and 1 for y. So I have 4 squared plus 1 squared squared. And then I want it to prove that it equals 4 squared minus 1 squared squared plus 2 times 4 times 1 squared. So since I'm proving that it works, I can only keep my math on the same side of each equation. So 4 squared is 16 plus 1. Over here, I have 16 minus 1, still stays squared. Then 2 times 4 times 1 is 8, still squared. Okay. On this side, I have 16 plus 1, which gives me 17. Over here, I have 16 minus 1, which gives me 15. 8 squared is 64. Then I don't know 17 squared. 289. Don't know 15 squared. 225. Then left side stays the same. So I still have 289. And then I just need to calculate or prove that 225 plus 64 works. It does. That's all I need to do for this problem. I just need to plug in and show. So basically when it says prove, it's just asking me to show my work. Okay. Same thing on number 16, I'm plugging in the same numbers. So I have 7 squared plus negative 2 squared, and it should equal 7 squared minus negative 2 squared plus 2 times 7 times negative 2 squared. Okay. 7 squared is 49. Negative 2 squared is positive 4. Remember, if I'm typing a negative number on my calculator, I always want to type it in parentheses. So if I do this, it gives me positive 4. Okay, this whole thing is still squared. Equals 49. This time it's going to be minus 4 because of the negative out front. Squared. Plus 2 times 7 is 14. Times negative 2 is negative 28. Over here, I want to add 4 to 49, which gives me 53. Over here, I subtract, and I get 45. Negative 28 squared, not a number I know. 784. Next line, I don't know 53 squared, which gives me 2809. Equals 45 squared, I do not know, so I'm going to type in the calculator. 2025 plus 784. And then all I need to do for my last line is check on my calculator that 2025 plus 784 adds up. It does. So remember when I do this on the test that I write my final thing, my final statement, that whatever it equals itself. Okay. Number 17 tells me that my favorite math teacher has started a tutoring club where students are paired with children at the local elementary school to help them better understand their homework. The table lists how many requests for high school tutors that the teacher has received each week the program has been in place. And it wants us for A, so use finite differences to find a polynomial model for the data. So this is the one where I go and count the differences. So to go from 1 to 3, I add 2. To go from 3 to 7, I add 4. Go from 7 to 14, I add 7. 14 to 25, I add 11. This is not the same, so I keep going. To go from 2 to 4, I add 2. To go from 4 to 7, I add 3. To go from 7 to 11, I add 4. Still not the same, so I keep going. To go from 2 to 3, I add 1. Go from 3 to 4, I add 1 again. So this took me 3 tries. So the number for an exponent of 3 is cubic. So on my calculator, I am going to type this into my table of values. I'm going to stat, edit. I'm going to clear out my list if they have numbers, and then I'm going to type this one in. My month is L1. My P is L2. It's not even on the screen. So I type those in. Then I second mode to go back home. And then I go stat, calc. Since this was cubic, I want to pick the one that says cubic, which is choice 6. And I press enter, and the calculator gives me a bunch of numbers, so I'm going to plug these in. So I have y equals, I have a equals 1.666, so I'm going to just do 0.167. On the test, it will give you nice numbers. X cubed. For b, I have a 0, so that means I don't need to write the squared term. C gives me 0.83, so plus 0.83x, because C went with x. And then D also has 0, so I don't have to write that one. Okay. On B, it wants me to use my model to predict the number of tutors after 7 weeks. So what this means is plug in 7 for x. So I have y equals 0.167 times 7 cubed plus 0.83 times 7. So then I just type this into my calculator. What am I doing? 0.167 times 7 cubed plus 0.83 times 7, which gives me approximately 63. Because, remember, I'm talking about people. Okay. Number 18 works the same way. This time I'm working at a coffee shop though, and I'm bored and I'm counting how many customers are coming in each hour I'm working. So, same thing, I want to start off by using my finite differences. To go from 20 to 4, I have to subtract 16. 4 to 0, I subtract 4. 0 to 4, I add 4. 4 to 16, I add 12. 16 to 40, I add 24. If I ever don't know, I always take the second number and subtract the first. So on that last one I did, 16 and 40, if I wasn't sure, I would do 40 minus 16 to figure out that I have to add 24. Okay, so those numbers are not the same. So I want to keep going. To go from negative 16 to negative 4, I add 12. To go from negative 4 to positive 4, I add 8, because I have to change signs. To go from 4 to 12, I add 8. 12 to 24, I add 12. Not the same. This one, I subtract 4. I don't do anything. I add 4. Then this one, I add 4, and I add 4. So this one took me 4 tries. So this one is quartic, like quarters in a dollar. So I'm going to go in. I'm going to type this into my table of values. I'm going to clear out my list. Oops, that was 4. And this time when I go to stat calculate, I want the one that says quart regression. I pick that and I press enter. Then this one I'm going to plug into my formula. So I have y equals, I'm going to do 0.167 x to the 4th minus, because it's negative, 2.33 x cubed. This one's positive, so plus 15 point, I shouldn't have written this so close to the edge of my paper, 83x squared. D is negative, so I'm going to do minus 49.67 x. E is positive, so plus 56. Okay, then I want to use this equation that I just wrote down to predict how many customers will come in after 7 hours of me working. So again, 7 gets plugged in for x. Okay, so then I want to go ahead and type this into my calculator. This gives me 85.75. So about 86 people. And like I said before, on the test, it'll be nice, easy numbers.